Alright, so I'm going to show you how to complete challenge 2 of Damn Vulnerable DeFi called Naive Receiver. So there's a lending pool offering out quite expensive flash loans of Ether, and this pool has 1000 ETH in its balance, and a user has deployed a contract with 10 ETH in its balance, which is capable of interacting with the lending pool and receiving flash loans of Ether. And our job is to drain all ETH funds from the user's contract, and we should try and do it in a single transaction. Alright, so I'm going to show you the contracts now. So this is the main lending pool contract. First is just the fee for completing the flash loan, and this is just a function to return that fee. Next is the actual flash loan function. It takes in two parameters: the borrower contract address and the amount of ether that is wanted to be borrowed. And this is just getting the balance of the contract before the flash loan has taken place. And here's a require statement, just making sure that the balance of the contract is enough to be able to fulfill the flash loan. Next is making sure that the contract calling the flash loan function is actually a contract and isn't a account. And here is a function for giving the ether to the borrower contract, and we're sending the amount of ether that was specified in the borrow amount parameter. And finally, there's a require statement to check that the balance of this contract is greater than or equal to the balance before plus the fixed fee, which basically just makes sure that the flash loan has been paid back. And here's just a fallback function to allow deposits of ETH into the lending pool contract. Alright, let's go to the interaction contract now, which is called flash loan receiver.sol. Alright, so these few lines here are just for setting up the pool address, and here's the actual receive ether function, which is called over here, and it's to, well, receive the ether. First, it requires that the message.sender, so what called this function is actually the pool, and then it makes sure that the amount of ether in this balance is enough to be able to be repaid to the actual flash loan contract. And here's a function that doesn't do anything, but it's for the logic, if there was any logic to take place during the flash loan. And finally, the function returns the funds back to the pool, including the fee of 1 ether. Alright, now I'm going to explain how you attack this contract. So what you do is, because you're able to call any contract to have a flash loan, we can call the flash loan receiver contract on behalf of that contract's owner, and what will happen is it will force the flash loan receiver contract to continuously be paying the 1 ether fee back to the naive receiver lending pool. And I drew a crappy MS Paint diagram to show you. So in our attack contract, we make the pool call a flash loan on the interaction contract, and it keeps on sending the 1 ETH fee, and after we do that 10 times, the 1 ETH fee 10 times will drain the interaction contract and put all that ether back in the lending pool. Alright, so now I'm going to show you how you implement that exploit. So to implement the exploit while doing it in a single transaction, you have to build an attacking contract. So I put the attacking contracts in the attacking contracts folder, and I called the contract attack naive receiver. Alright, so for the first few lines of this attacking contract, we're just setting up the pool with the right address. And next is the only function that's in this tagging contract, which is to drain the balance of the victim, which is the flash loan receiver contract. And what we do is we call a flash loan on that victim contract, which is specified through the address as a parameter, and we're going to send 0 ether for the flash loan. However, the 1 ETH fee will still continuously being paid back, even though the user is taking out 0 ETH in the actual flash loan. The 1 ETH fee will still be paid. So now all we have to do is deploy the attack contract and call the drain function with the address of the victim's contract. So now all we do is go into naivereceiver.challenge.js, and these first two lines are here to deploy the attack naive receiver contract with the constructor argument of the pool's address, and we need to make sure this pool's address is payable to be able to interact with it properly. And then all we do is we call drain on the victim's contract, which is the receiver's contract, which is this.receiver.address. And once we've done that, all you need to do is test out the exploit by going to do npm run the name of the challenge, which is naive receiver, and then you wait. And then boom, we just completed challenge 2 of damn vulnerable DeFi naive receiver.